Okay. So let me get started. So the slide is presenting appropriately in the screen. But thanks again for the opportunity for this presentation on the West Cabarrus Street mixed-use project. We're working on for Kane Realty and Clancy and Thays Construction Company. Again, my name is Andy Padiak. I'm a group manager here at McAdams. And McAdams is a civil engineering firm headquartered in Research Triangle Park. We also have an office in downtown Raleigh, really close to the subject site. And we have additional offices in Charlotte and Dallas as well. But I specifically work in the commercial department where we specialize in office, retail, like urban apartment projects, most often in mixed use developments. And McAdams also does large and small residential single family subdivision design, institutional projects, public and civic projects throughout the state and beyond. So we also have a large surveying department and planners that specialize in land planning and rezoning. So I'm fortunate to be surrounded by such an excellent team of folks. But since the beginning of my tenure with McAdams over 15 years ago, the main client I serve is Kane Realty. And Kane is most well known for the redevelopment of North Hills Mall, including the development on the east side of Six Forks Road, where we creatively refer to that as North Hills East, and more new land under development further down St. Albans Drive towards Wake Forest Road that we refer to as the Far East, but all collective, it's North Hills area in general. So for today, I wanted to present a handful of topics related to the West Cabarrus Street mixed-use development that we're currently kind of finishing up the preliminary site planning efforts on. I want to present to you the history of the site, some contamination issues present on the site. What is the proposed development? What do we plan on constructing on the site? We ran into some significant storm drainage issues that we had to overcome, and West Street extension coordination, because the city has a planned project to extend West Street underneath the railroad tracks, which is immediately adjacent to the subject site. And then there's some tricky sequencing of construction that I want to touch on, as well as the permitting process that we're navigating through with all the municipalities and agencies that we need to get permits from. And we'll leave time at the end for questions and comments. So moving on to let me tell you a little bit about where the subject site is. The site, it's 6.82 acres, so just shy of 7 acres in 3 parcels. I've highlighted it on the slide, and it is directly, it's within Raleigh's historic warehouse district, and it is zoned IX7 UL, so it's up to 7 stories max, in industrial mixed use up to 7 stories, and as defined by the Raleigh Unified Development Ordinance, which we call the UDO, Unified Development Ordinance. But the property does consist of 3 parcels, and they're owned by Clancy and Thays Construction or Clancy affiliated companies. The site is bound by the dead end of West Street on the east side of the site, and along the southern boundary of the site is Cabarrus Street, and along the western edge of the site is DuPont Circle, and the North Carolina Railroad and Union Station is along the northern property line. So currently, Clancy and Thays Construction Company's offices and operations are located on the parcel that I'm pointing at on the screen, and the Amtrak's Administrative and Support Center leases a small little chunk of property right here on West Street, and the North Carolina and the remainder of the property is owned or being used by the Haven House and Clancy and Faye's laydown yard. So that's the bigger parcels, a lot of space for Clancy and Faye's to store equipment. So moving on to the next slide, I wanted to tell you a little bit about the history of the site because I find it to be very interesting and I hope you do as well. The site, on the picture on the screen, let me point out that we have West Street along the bottom part of the picture, and the main primary street you see is Cabarrus Street along the southern side of the site, and DuPont kind of wraps the northern, well, it's really the west edge of the site, but towards the top of the picture, DuPont makes that almost 90-degree curve. So that's what the subject site looked like back in the 40s. But the site itself had an important role in Raleigh from the early 1800s. In 1833, the first railroad in the state was completed in Raleigh, and horse-drawn wagons hauled quarried granite from this site, coming off the train, to the construction site of the new state capitol. So that's 1833. At this point in history, riding the train is a very popular means of entertainment for Raleigh society. So the railroad served an important role to the city for commerce and entertainment. And you can see from this picture that there's a whole lot of railroad tracks on the right-hand side of the picture, which is our northern property line. In 1840, Raleigh and Gaston Railroad is chartered, where they opened up 86 miles of track across the state. That year, Raleigh only had 2,244 people and was the fourth largest city in the state. And they celebrated completions of the new railroad and the new capitol that year, so 1840. And moving into the late 1800s, so 1892, Union Station opened. So Union Station's exactly on the north side of the railroad tracks from the subject site. So this is when the property was developed with a phosphate fertilizer processing facility. So this is 1892 is when it was first developed with that phosphate fertilizer processing facility. And by the early 1900s, it was home to a lumberyard and manufactured gas plant, which operated at the site from 1916 to 1953. So on the slide, I'll try to point out here if I could, the lumberyard is at the corner of West Street and Cabarrus Street. So this whole area is the lumberyard, and the remainder of the site was the manufactured gas plant facility. So from the 1800s through the mid 1900s, before natural gas was available as an energy source, the manufactured gas plant existed here and many others throughout the state and the United States. These plants use coal and oil to produce gas for lighting, heating, and cooking. So that's why the railroad was critically important, because that's how the coal got to the plant, from the railroad. And when they unloaded the coal from the railroad carts, they basically unlatched the side of it and the coal fell onto the ground. And then men would shovel it up into wagons hauled by horses, and that's how they got the coal around. So that's, if you can imagine, an opportunity for contamination occurred for sure. The manufactured gas plant facility was referred to as the Raleigh Manufactured Gas Plant number 2, and it was first owned by the Raleigh Gas Company and then until 1943, and then by the Public Service Company of North Carolina. So PSNC, which now is called Dominion, has owned it ever since. So the historic lumberyard was located right here at the corner of West and Cabarrus, like I mentioned. That's this area here in the picture. And that's where Clancy and Faye's offices currently reside today, as well as the Amtrak operations building right there on West Street. And then predominantly where the manufactured gas plant was located is now occupied by Haven House and Clancy and Faye's equipment and material storage yard. So moving on to the contamination that occurred because of that gas plant. So the most important environmental matter is that former manufactured gas plant facility and the contamination it caused, primarily on the larger parcel, which is along DuPont and the railroad tracks. So PSNC completely dismantled and demolished the gas plant by 1989. And in 2001, they entered into an agreement with the North Carolina Department of Environmental Quality to address the contamination caused by the gas plant's operations for all those decades. So starting in 2001 and ending in 2011, so a 10-year period of time where PSNC implemented a series of comprehensive, large-scale cleanup actions that included the removal of approximately 38,000 tons of contaminated soil and other response actions, other cleanup activities. There is, however, some residual pollution below grade in the soil today and in the underlying groundwater at the property, which need to be considered for our redevelopment. But for the most part, the worst of it was eliminated from the site and disposed of properly. So because the site was largely cleaned up in that 10-year period from 2001 to 2011, we do not envision major environmental issues that will materially interfere with the site's redevelopment. The site is now currently part of a brownfields agreement, and the brownfields agreement, authored by an engineer named John Gallagher, it really sets forth some fairly reasonable requirements in the form of administrative land use restrictions to ensure the site is redeveloped safely. The agreement requires that there's no active remediation going forward, because that is theoretically already been done in that 10-year period where they eliminated the 38,000 tons of material. But the agreement does allow for mixed-use development, including commercial and multifamily residential. So the brownfield agreement does cover proper handling of contaminated fill if we encounter, which we will encounter some upon redevelopment, oversight on what to do with additional contaminated material, disposal, dewatering, and other protective measures to keep people safe during construction, and also for people that will ultimately live and work at the site one day when it's redeveloped. So there's some nasty stuff, but hopefully that's mostly in the rearview mirror at this point. So one more thing about their gas plants. There were about 25 manufactured gas plants in the state, and they produced the burnable gas processed by processing coal. And there were about 4,000 of these plants in the US that operated for about a 60-year period from the late 1800s to the mid 1950s. And when natural gas became available in our cities and towns, these gas plants were shut down, and they produced such serious pollution conditions here in North Carolina that there was a dedicated group set up to work with utility companies on cleanups. Somewhere on the order of $25 million was spent cleaning up the plant on this particular site. So let me introduce you to the proposed development concept. The owner and the architect are still in the preliminary stages of design for the buildings themselves, but the engineering aspects of the site-related items I will discuss today remain the same, independent of what the final design of the buildings will ultimately look like. So the slide you see on the screen illustrates very conceptually, very basic illustration of the proposed development, which consists of 2 office buildings, an apartment building, and a parking deck to serve both the uses. There will also likely be a retail or restaurant component in the first floor, incorporated into the first floor of some or all of the buildings. We really want to have a true mix of uses. Note the top of the slide is north, and downtown Raleigh is to the top and the right of the slide, and the railroad tracks run along the northern boundary. And West Street is to the right of the blue buildings, and DuPont is to the left or the west of the yellow apartment building, and the parking deck is shown as gray. on this illustration, just to give you a feel for generally 3D how the project may look in the future. So the uses are laid out on the site this way on purpose. The idea is the office buildings are on the side of the site that face downtown. So on this illustration, same thing, downtown is northeast and east of this of the site, with north on the illustration being straight up. So we want the office buildings facing downtown where there's more urban density, and the apartments are on the western side of the site where they face predominantly residential neighborhoods beyond. And likely the offices will be taller than the apartments, so the height also transitions from the urban northeast area to the more residential southwest area of the site. So the building placement and scope were by design on purpose to fit into the fabric of the overall development in the area. Both offices and the apartments share the parking deck, and the parking deck is specifically connected to the apartment building so that the residents can have quick access to their units without walking outside. That's highly desirable for those folks renting an apartment. And the office tenants will need to cross a private drive, a private street in the middle between the offices and the residential building to get to the deck. This is a view of the proposed building, and it's looking at the south side of the apartment project from a vantage point of Cabarrus Street. So Cabarrus Street is in the foreground in this illustration, and the offices are over to the right on this picture, a slightly different color brick in this illustration to give you some perspective. So this is looking north, Cabarrus Street in the front, apartment is predominantly in the vista, and offices off to the right. This is a view from the intersection of the internal private street, which is on the right there of the picture, and Cabarrus Street, which kind of goes off on the left of the illustration. And the parking deck is in the back, but the parking deck is clad with a layer of apartments to make it such that you can't really tell it's parking deck. And this is a view from the west with DuPont Street. And these are apartments with some potential retail and restaurants or restaurants on the first floor. And the goal is, meeting the City of Raleigh Unified Development Ordinance, or UDO, to really activate the street with street trees along back a curb, nice wide urban sidewalks, opportunities for seating and trash cans and bike racks and such, and a lot of entrances out onto the street, such that it really becomes not a dead space, but a very active and lively space. This is a view of the two office buildings from the east along West Street. So West Street is on the east of our project. So it's but this is looking with West Street in the foreground, and Cabarrus is on the left side of the picture. But this is a pretty good illustration of what the office buildings may look like. And I really appreciate the architecture. I wanted to note that the architect for the offices is Payne Architects out of Durham, and the architect for the apartments and parking deck is Klein Design right here in downtown Raleigh. So some of the things from a civil engineering standpoint, now that I've kind of went over the history of the site and introduced you to what the final product may look like, what we're trying to achieve, we ran into some very specific site-related issues that I'll spend a bulk of my time talking about, and of course be able to address any questions you have at the end. One of the main issues was related to storm drainage. There is an existing 5x5 box culvert that runs from the northern property line at the North Carolina Railroad, extending south through the site to the south side of Cabarrus Street. And I'll try to point to it on the screen, but the yellow line are the 3 parcels that comprise our subject site. And where it's labeled 60, that's really a 5-foot by 5-foot box culvert. It starts right at the railroad, goes right through the middle, all the way under Cabarrus Street, and daylights along the Rose and Garden Alley on the south side of Cabarrus Street. The box culvert itself is not in good condition. It is also grossly undersized for the drainage area that we're taking on. In addition, there's a known flooding condition on the north side of the railroad tracks at Union Station. So this is a picture off IMAP. So there's a cluster mess of red lines, but right in that general area on the north side of the tracks, there's a place where during large storm events, water gets like a few feet deep at the entrance to Union Station, right at the end of West Street. And I have some pictures that I'll get to in a minute that will illustrate that a little bit better. But we're trying to solve 2 things. We're trying to get the stormwater through our project and size the culvert appropriately, the new culvert. And we're also trying to solve an issue that's on the north side of the tracks. So we had a handful of iterations to eventually get to where we are today. And I'll walk you through a couple steps that we took in order to get to this point where we believe we have a solid solution. Our initial solution to the storm drainage issue was to connect the existing 48-inch pipes that daylight on the south sides of the tracks to a large junction box. So I circled in red, there's 2 existing 48-inch diameter pipes that come out in daylight. They're bringing the stormwater from the north side underneath the tracks, and they just dump it out into a riprap area right now before it goes into the 5x5 box culvert that exists today. So those pipes really are the problem in why Union Station floods, is because they need to be much, much bigger. In fact, instead of twin 48-inch pipes, they really need to be twin 72-inch pipes. That's quite a big difference. So in our initial design, we said we would build a storm structure at the end of the dual 48s, existing dual 48s, turn it 90 degrees, and then extend the new dual 72-inch pipes parallel with the railroad right-of-way, highlighted in yellow there, to another junction box, and then turn it 90 degrees again. And then basically bring a large culvert down our private street all the way to Cabarrus, take another 90 degrees, follow the right-of-way of Cabarrus Street, and then take another turn and finally daylight out at the Rosen Garden Alley down there, which is exactly where the 5x5 box culvert drains today. So that was our initial strategy, and we met with the North Carolina Railroad team and presented our proposed storm drainage plan. And they were really not comfortable with the storm drainage structures within their right-of-way. Their preference is for any storm drainage needed by our project to be located outside of the North Carolina Railroad right-of-way. The railroad just simply does not want to maintain additional storm drainage other than some incidental drainage at the passenger loading platforms and the necessary perpendicular crossings. So they just want to keep it very minimal, because any more piping and structures that exist in the right-of-way is just more cost and worry that they need to keep up with for long-term maintenance. So the railroad is also not interested in entering into private agreements with private landowners or developers to allow the private landowner or private developer to maintain the system. They don't want anybody in their right-of-way. You know, you can imagine the liability and the safety reasons associated with that. So we had to do a lot of explaining about why our development program required the private street to be shown like it is on the plan. You can see, I kind of stressed that we have large diameter pipes with significant, like 90-degree turns in 4 places. So this, of course, never sits well with anybody, not the city of Raleigh, not the railroad, and honestly, it's not the best engineering practice, but sometimes you have to do things and really make sure that you build them in a manner that they will last for the very long haul, and that they're not necessarily ideal, but they're needed to be that way to accommodate whatever the proposed development may be. So it would have been better for the city and the railroad if the new box culvert through the site basically followed the same path that the existing box culvert follows, because the existing box culvert basically follows a straight line right through, you can see our proposed apartment and parking deck. But really, in order for the project to be viable from a financial standpoint and desirable for the end users, the apartment building had to have a specific number of units, and the office had to have a specific square footage, and the deck had to be connected to the apartment building. As I alluded to earlier, the value to those renting apartments having the deck connected to it is important. And the uses had to be positioned on the site for the proper transition from urban downtown to the northeast to residential neighborhoods of the southeast. So there were a lot of metrics that the developer had to have in order for the project to even move forward from like a marketability or even like a financing, or the density drove their whole performance. So that's what really the root of the issue was, is that we want to turn our stormwater, our drainage 90 degrees a handful of times, and that's just not desirable. So we kind of got stuck there for a bit. And then the next slide I'm presenting here shows our first reaction to mainly an alternative to having large junction boxes and dual 72-inch storm pipes within the NCRR right-of-way. They were opposed to that, so our way around it was we collectively worked with the railroad staff to design an alternative that included a rip-wrap lined plunge pool at the outlet of the dual 48-inch pipes at the railroad tracks. And I circled that in red on the slide, and that's not very different than the existing condition, because the existing condition, the stormwater comes out of the twin 48s, dumps into a rip-wrap plunge pool, and then it enters the 5x5 box culvert at our property line. So we would basically be doing about the same thing, and we would extend that riprap to the east to marry up with a head wall, which would be the entrance to our new box culvert through our private street. So if all that was lined in riprap and properly sized, and the depth of the channel was deep enough, it was reasonable to the railroad for that solution to move forward. However, at a subsequent meeting, and then when we really started studying that design and realizing that we really couldn't get the depth of the channel to be enough to accommodate the 100-year storm with some safety factor, with some serious safety factor built on top of it, it basically we became ourselves uncomfortable with doing this as a strategy either, considering we have a brand new parking deck sitting right adjacent to this place where we want stormwater to make a hard turn. So we sharpened our pencils again and met with city staff and met with the railroad and arrived at what we feel like is the right solution. So after a lot of coordination with railroad and city staff, this solution checks the box for everybody involved, and from a preliminary standpoint, we have preliminary approval with this solution you see on the screen. We propose to bore and jack dual 72-inch steel pipes underneath the railroad tracks. And so recall that there's dual 48-inch pipes in the existing condition. So the new pipes will be absolutely increased capacity enough on purpose to alleviate the flooding condition at Union Station to the north. So that was the big win there, is that it comes with a cost of an expensive boring and jacking operation, but it was a necessary thing in order to fix the flooding issue at Union Station. Also, the railroad gave us some relief in allowing a skewed crossing of our new pipes at the railroad tracks. a typical standard for the railroad is they want any crossing of storm pipes to be certainly perpendicular. And so for them to give us some relief to allow us to skew it, that was a big win because it enabled our new twin 72s coming under the tracks to align with our private street, and it eliminated a couple of those 90-degree bends that we were all concerned about. Once the storm pipes enter our site, which is right at the northern property line, we switch to a box culvert at that first junction box, and we continue with the box culvert all the way through our private street and down Cabarrus to the outlet. And the purpose is the box culvert is more compact horizontally than the dual 72-inch pipes with 1 foot of space between them. So, and the installation of the box culvert is faster than it is to put 2 pipes in. So it's a smaller footprint, and it's a little faster construction. So for those reasons, that's why we switch from the 72-inch steel pipes at that junction box to a concrete box culvert the rest of the way going to the south. So on this slide, this picture shows our profile from our hydraulic calculations for the 100-year design storm. So Union Station, I'm going to go from right to left. Union Station is on the right, with the private street being in the middle, and West Cabarrus Street is on the left. So we'll have some buffer impacts ultimately at the bottom to provide a significant riprap dissipator pad at the culvert outlet on the south side of Cabarrus as well. But predominantly we're designing a 12 by 5 box culvert in some areas where we have room to provide the 12 feet of width, but we lack the cover to provide anything more than 5 feet in height. And this is the case on the private street. I'm not sure how well you can see it, but you can see how our cover condition on the upper reach of the private street is very little. It's only a couple feet. So that's why we had to go with a box that was wider and shorter. However, at some point when we start going a little further downstream, the next junction box, we would change it to a culvert, a box culvert that is taller and narrower. So something that's more standard and more readily available than the 12 foot by 5 foot. So we've preliminarily are working with the contractor to value engineer that, but it looks like an 8 by 8 or a 10 by 6 would be more readily available and a little cheaper. So we definitely don't have as much of a cover issue in the vicinity of West Cabarrus Street than we do further up closer to the railroad tracks. So this size change became logical. So basically that solved the storm drainage issue for Union Station. It was a design that is in a preliminary manner approvable by the railroad and the city. And at this point in time, we're getting ready to move on to more of a final design, construction drawing plan set over the course of the summer. We'll be working on that and getting that submitted to the appropriate agencies for approval. But it took a lot of communication and meetings and coordination with the railroad and the city to get to that point. And we feel very happy and lucky that we're able to satisfy all parties and everybody's comfortable. So another significant issue that we had to overcome on this project is how to manage the West Street extension, which will be a city project in the future. And so when Union Station was constructed, West Street was extended to the railroad tracks. So this is looking south on West Street. You can see a concrete wall with obvious indications that the road will obviously ultimately go straight under the railroad tracks. And right around the corner as you enter Union Station is where the flooding issue occurs. So when you take that right there, that low point in there is where it gets to be a couple feet deep of water during the big major storms. But ultimately, the city's plan is for West Street to go straight under the railroad tracks. Our West Cabarrus Street project is located just beyond the railroad tracks and to the right of the Union Station passenger loading area you could see off in the distance. So this picture is looking north on West Street. As you can see, West Street is basically flat and would closely set up for an on-grade crossing of the railroad tracks. If it didn't dead end, it would be pretty much in line with the existing tracks. And the West Cabarrus site is on the west or the left side of this picture, where that one-story brick building and a lot of trees and vegetation exists today. So what we're trying to achieve is our project will construct the City of Raleigh UDO, Unified Development Ordinance, required street section for West Street up to the southern railroad right-of-way, which is the shared property line for the West Cabarrus Street project. So on the profile, I tried to identify this location as with the green arrow. You can see that that's about where the railroad right-of-way is. And that's where our project property line ends and the railroad begins. And you can see, well, first of all, the UDO only requires us to construct the street section on our frontage and only up to the center line. So we are required to improve our half of the street. So the additional complexity with this project is that the ultimate grade of the center line needs to be such that it follows the proposed design by the City Transportation Department in cooperation with the railroad to extend West Street under the 4 sets of tracks using a series of bridges. So what we had to do is receive this information from the city, what their ultimate design looked like, and then we've got to build our half of West Street, and our project is highlighted with red, both in plan view and in profile. We have to cut West Street down and dead end it, just like they do on the north side. So in the future, the city project can take it from there and connect the dots between the two. So the blue line on the profile shows the future center line grade of West Street. And looking again at the green arrow, you can see how much we need to lower West Street from the existing condition. It's basically around 10 feet at its worst point, 10 or 11. So in addition to improving West Street, our project is responsible for widening Cabarrus Street and DuPont Street, or DuPont Circle, to match the UDO requirements. And this will involve approximately 5 feet of right-of-way dedication, installation of street trees between back of curb and sidewalk, and a new 6-foot wide sidewalk at a minimum all the way around the building. Because of the urban nature, we're going to be bringing sidewalk mostly to the building face, and they'll be much wider than the city required 6-foot sidewalk. So this next slide is, it's looking at West Street across the frontage of our office buildings. And you can see from this graphic, I specifically put it in here because you can see how much the road is going downhill to the right, with West Street going down to the right. And we start to reveal like a basement condition on that office building to do so. So next I want to touch on, watching my time here because it's going by quick, is the sequence of construction has some complexities that we started the preliminary planning for. And I want to just briefly touch on a couple of those, and then I'll finish with just highlighting what our permitting timeline looks like before the question session can commence. So the goal for every project is to do enough site work to establish the building pad and get the vertical construction of the buildings underway as quickly as possible. So in this case, the installation of the box culvert through the site is certainly on the critical path, along with the demolition of the existing buildings. So furthermore, the box culvert would need to be installed from the outlet, which is at the bottom south of Cabarrus, working upstream towards the railroad tracks. So once the buildings are removed, sediment basins and silt fence and diversion ditches, et cetera, will be needed to control sediment runoff from the disturbed areas. So what we envision are 2 sediment basins located on, as shown on the slide, that are out of the path of the culvert installation and outside of the footprint for the first office building and the parking deck. So they would build office building number 1, and they would build the deck first out of all buildings after the storm box culvert is installed. So the goal is to get the site to proposed grade by working from north to south, stabilizing the surface with ABC, and maintaining perimeter erosion control measures such as silt fence. The contractor will work with the city inspectors to get permission to eliminate the sediment basins as soon as the disturbed areas are safely stabilized. So the goal is to get it up to grade and then fill those basins in when there's a lot less risk of sediment runoff because the disturbed area is mostly stabilized. So I want you to note that the existing 5 foot by 5 foot box culvert shown as a green line will need to stay in place until the new box culvert is installed and operational. So if it rains, we need to make sure that we don't create a disaster by having that. We got to have that existing box culvert operational up until that point in time when the new box culvert is completely installed. So this next slide shows the work along West Cabarrus Street. It will absolutely be disruptive, and there's really no way around it. The slides shows storm drainage in green, sewer in red, water in blue, and the gas line in yellow. So there's a significant gas farm, a remnant from PSNC in the corner of DuPont and West Cabarrus that happens to have an 8-inch gas line coming out of it. So you've got to be very mindful of that. So the box culvert will be installed first, and the goal is to come in right behind it with the sewer, water, and gas in the West Cabarrus Street right away. So between traffic control, pedestrian detours, service interruptions, this work will be so carefully choreographed to minimize how long services and access are down. But you can see how on the profile that's on the left side of the slide that the significant box culvert would have to go in first and these other utilities go above it. The sewer just wouldn't drain out if it was below the box culvert because it'd be too deep. And water and gas can go above it because there's enough cover between the surface of West Cabarrus Street and the utility. So in the remaining time, I wanted to at least touch on the permitting process so you had a feel for what that looks like. And I may have to hurry through this a little bit, make sure I leave some time for questions, but the permitting process and associated timeline are critically important to developers as they structure deals. We spend a lot of time forecasting how long the permitting steps take, what level of design is needed for each step, and what items we need from all the other consultants, architect, mechanical, electrical, plumbing, et cetera, at each point in time. So I boiled down the permitting process into 6 basic steps for the purposes of this presentation. The city processes are in sequence with each other, meaning that no overlap opportunities exist to do steps concurrent to each other. The first step is the administrative site review. We call it ASR, is what Raleigh calls it. And during this time, there could be anywhere between 3 and 6 or more reviews to get all the plans and calculations revised and all city comments addressed before they can be approved by the city staff. And the goal is to obtain preliminary approval for the project, which is an entitlement to the number of units, square footage of office, retail, et cetera, that we're allowed to build on the site. And we need to demonstrate how the proposed development can be served by public utilities and how we're proposing to manage stormwater. We identify public improvements, street improvements that are required to serve the development. And by the time the ASR gets approved, we know we can move forward to final permitting and that the project can be built. So it's a big milestone. The next step is the site permit review, also we call SBR is the acronym. So the SBR is where we provide detailed construction drawings for every aspect of the project. We usually use the ASR as like a base, and we add in the plan profiles, cross sections, construction details, 1 million detailed spot elevations, all kinds of calc books, and everything, final design of the stormwater management, et cetera, to basically triple the size of that ASR set to become the final SBR or construction set. And after the SBR approval, all site work can begin. So that's a big milestone. And we move on to recording a plat or preparing a plat, getting a plat approved, and ultimately recording it to dedicate rights of way and easements and site triangles and all kinds of stuff. But the recorded plat and the approved SPR are the tickets to allow the architect to move forward with the building permit. So they cannot move forward to get a building permit until we have the site-related elements buttoned up in the form of the SPR approval and the final plat recordation. So while we're navigating the city process, we got to keep our eye on all the extras. In this case, we have a North Carolina Railroad permit to obtain, and we also have some state permits for buffer impacts to obtain. So we'll do that along the way. We have to have those in hand before the SPR can be approved. And then, so here at McAdams, we prepare a permitting schedule for every project at the beginning, and this will set the expectations for our clients and basically help them make important financial decisions. And we also make every effort to team with the city, the railroad, in this case, the DOT, and any other agencies involved, so we can work together to get through this permitting process as efficiently as possible. We do pride ourselves in our relationships with staff. You know, we work hard to do the right thing, and we work to partner with staff for a successful project. And success is really driven by having a good game plan to follow, and then really having buy-in from everybody that is a participant along the way. So let me conclude here by saying I believe this project will transform that corner of the city by getting the best and highest use of the property. The quality of the project will be high in terms of initial construction quality, how it's maintained and operated for the long term, and really the thoughtful design that is going into it. The ultimate connection of West Street in the future will make West Street a significant southern gateway into downtown. It would also allow an at-grade crossing of Cabarrus Street in the railroad to close, because right now Cabarrus runs across like four sets of train tracks, and in the future when West Street extends, they're going to close that, so they won't do that anymore. And so it'll be just a safer condition for vehicular and pedestrian safety in the general public. But we're happy here at McAdams to be connected with Kane and Clancy and Faze on this important project as we move into the next phases of design and permitting. You know, at this point, we estimate construction start to be somewhere in 2021, depending on how the economy fares in this crazy pandemic that we're dealing with. But I just want to conclude to say thank you for your time and the opportunity to present this project. And I will now take some time to address your questions. Let's see. Okay. So first question is, why couldn't a concrete poured in place box culvert be run under the buildings in a straight line? Did the grade get in the way or couldn't be built deep enough? So we did have that as an option on the back burner. However, what happens is that that kind of design is not looked favorably upon by the city, first of all, and certainly not by us, because ultimately running any kind of utility transmission underneath the building is a bad idea. If it needs to be replaced or maintained, repaired, it just radically could radically affect the building itself. And not to mention the foundations for the building wouldn't be able to put load on it. So you end up with additional foundation costs to not, you know, cause that culvert to support any load from the building. So it would be highly unusual. We do have a project at North Hills where the JCPenney's is being redeveloped in the coming years, where we can't help it. You know, there is no other choice to do exactly that. But if we can avoid it, we will. So that's what we ended up doing in this case. So the second question, and this was a challenging project. What was the single biggest challenge? And I really think that I did dwell a lot on the stormwater issue because of the complexities of dealing with the railroad, and they have their rules and they have their timelines. And, so I think that was by far the one element of challenge that we scratched our head and really were concerned that it might radically change the scope and the look of our project to find a solution that satisfied the railroad. Another question is, how did landowners on the east side of West Street react to lowering West Street to the north of that street? Who is responsible for that cost on the east half of the street construction? So there's a really good question. We basically reached out, and the railroad actually owns property on the east side of West Street. And while they're very supportive of our project and they were wonderful to work with to help, solve the storm drainage issue, that they did not want us to encumber their property on the east of West Street with a grading easement in any way. So we luckily had enough right-of-way width for West Street to build our half of it. And in the other half, which is the east side of West Street, there's like a 2-to-1 slope or a 3-to-1 slope that goes up the hill and ties into existing grade before you cross the right-of-way line. So all of our work stays within the West Street right-of-way, and we did not need to obtain a grading easement from them. So how does the other half get built? Well, it would be upon the redevelopment of that eastern property. They would be responsible for picking up the burden of doing exactly what we're doing on our side of West Street. They would do the same thing to their side upon redevelopment. So was there any discussion of needing a sealed storm system due to the brownfield site? So good question. John Gallagher is the environmental engineer that authored the brownfield agreement. And we are getting to a point now, as we really start to work out the construction sequencing, to make sure that we balance the cuts and fills as much as possible to not haul off to save the cost of hauling off any contaminated dirt. We also are starting to study dewatering during construction. So if we dig a trench to put a giant culvert in and there's construction water to deal with, there's a plan for how to properly dispose of that. And then ultimately, once it's built, we're going to have O-ring piping, and O-ring, the box culvert will be sealed as much as possible. But we really are going to have one more layer of effort when we get to that point to consult with John Gallagher to make sure that we're doing all the things needed to comply with the brownfield requirements. So another question, which is the last question, what was the foundation support approaches to the building? Okay, this starts to get out of my area of expertise, but what I do know is the foundation systems to the buildings have to be deep enough, of course, to support the buildings and sit on bedrock, and all the stuff the structural engineer and the geotech engineer will coordinate. So that's a little bit outside of my area of expertise, but what I do know is that we care a lot about the building foundations not putting a load on the box culvert down the middle, and we will work closely with the structural engineer to make sure that the one-to-one loading plane from the bottom of the foundation doesn't put load on the box culvert in any way. We have to ensure that 30, 40, 50 years from now that you can dig up that box culvert and fix it or replace it without undermining the building foundation. So that's one thing we look out for mostly, but more about the foundations is truly from the structural engineer. Okay, I believe that concludes all the questions that I see coming over my phone here. And once again, I want to thank you for this opportunity